David Smith here with one more flipped classroom math video. 3 tips before we start. First, remember you can speed up the playback if that helps you get through the video faster. Just make sure you understand and keep up with your notes. Second, you can pause the video at any time to catch up with your notes or think about the topics. Lastly, you can turn on the captions and watch my words go by on the bottom of your screen.
Today's lesson shows you how to sketch the first and second derivatives based on the graph of the function. So we're not sketching super accurately here. We're just going to create a rough sketch. Remember, this is the IB word sketch rather than draw. So with a graph and a sketch, it has to be basically qualitatively correct, but not quantitatively accurate, if that helps. Okay, so here's our function, f of x, some function. You don't have the equation, so you can't really plot points, but you can tell what the derivatives are going to look like. So let's take a look at the first derivative. Remember that when the function is increasing, the first derivative is positive. When the function is decreasing, the first derivative is negative. So to accurately sketch the first derivative, we need to notice the turning points of the function. Because you'll remember, at a turning point, the function changes from increasing to decreasing or vice versa. So check this out. Our a here, I've labeled this point A. So this is one of the turning points. B is another turning point. C is another turning point. And then finally, D is our last turning point. Okay? So remember, function is negative. The derivative is negative when the function is decreasing. So here we are decreasing until we get to that turning point. So the function is negative here. So I don't know how negative, but suffice it to say that it's got to be below the x-axis. Now when the function starts increasing all the way to b, it's going to be positive. But when it hits b, the turning point, it's going to change to negative. So I can do this, like so. So in this interval, the first derivative is negative. In this interval, the first derivative is positive. When we pass this turning point, and between b and c, these two turning points, the function is going to be negative. So I can just sketch it like this. Comes back up, and then at c, the function changes to positive. The first derivative's value is going to be positive all the way through to this turning point, which is right there. So I can make my graph go like this and then back. And then at this turning point, the first derivative is negative. So the graph of the first derivative is going to go into negative land. Okay, so here is f prime of x. So roughly speaking, notice this is not an accurate graph, this is a qualitative graph. It just shows us that the first derivative is negative, then it goes to positive, then it goes to negative, then it goes to positive, and so on. Okay, let's make this graph a little more complex by graphing the second derivative of f of x. So before we do that, let's remember that the second derivative is positive where the graph is concave up and negative where the graph is concave down. So to do this accurately, we need to identify the inflection points. This is where the graph changes from being concave up to down or vice versa. So I've already graphed one of those in black. I'm going to use blue for the second derivative. So here we go. So this is a good assumption for where the graph is changing from concave up to concave down. Second point might be right there. If you're doing a graph, you should just make your best judgment about where those inflection points are. So here is the first inflection point. Here is the second. We're going from concave down to concave up. And then the third inflection point, I'm just going to put that right back here on the axis. So this is where we go from concave up back to concave down. So we have 3 inflection points in this function. So now, remember, the second derivative is positive where the graph is concave up. So we're concave up all the way to there. So what we're going to do is figure out where that hits the x-axis. That's right there. And so it's going to be positive until we get to that point. And now it's going to be negative until we get to the second inflection point where it goes back to concave up. So we could just sketch this in with a little loop like that. So this is negative, reflecting this concavity. Now we are concave up to here, after which we're concave down. So the second derivative, f double prime, is going to do that. So this is f double prime of x, or the second derivative. Now, this graph was a little confusing. If I put one of these on a test or a quiz, I'm going to have to pay attention and be careful when I grade your work. But basically, that's how to graph the first and second derivatives based on the function itself. Okay, let's do a second graph. Here we go. Here is f of x. Okay, so we've got curvage. This thing is symmetrical around the y-axis, so that's kind of nice. So without further ado, remembering what you learned from the last boards, go ahead and sketch f prime of x. Okay, let's see how you did. Now before I sketched it, I marked my turning points on my x-axis. Because remember, the turning points are where the first derivative goes from positive to negative, okay? So our function is increasing to this point, so that means up until here, the function is going to be positive. Now it's decreasing until that point. So now I can use my turning points to sketch the graph of the first derivative. And that's going to be positive to here, then negative to there, then positive to there, negative, positive, and negative. So this graph is just mapping whether or not the function is increasing or decreasing. And that's f prime of x, okay? Now, I want you to pause the video, grab a different color pen if you have it, and I want you to sketch the graph of the second derivative of that function. Okay, let's see how you did. Now, remember, to figure out where the second derivative goes from positive to negative to positive, you have to find the points of inflection, okay? So this graph, f of x, is kind of a little wobbly. I didn't make it super accurate, but I did with my inflection points. I wanted to capture with those exactly where the function looks like it goes from concave down to concave up. So I picked that spot on this function as this point where it went from concave down to concave up. So there's my first inflection point. I picked this one for my second inflection point right there. It's concave up, then it goes to concave down. Now on this one, I judged it to be a little different. So I picked that point as the point where it goes from concave down back to concave up. So I got that one. And then finally, this point I picked for right there when the function is going from concave up back to concave down. Now, if you picked different points, that's okay, but you do need to justify your points by saying, yep, that's the changing point from concave up to concave down. Okay, so if you haven't done that, if you just got that done, I would say pause the video and sketch the second derivative of f of x. Okay, now you can watch me do it. Here, we have concave down. So it's going to start off as negative to that point. Now we passed the inflection point, so now we're concave up. Second derivative is positive. Now we get to the second inflection point. Now the second derivative is negative. Third inflection point, second derivative goes to positive. And the fourth inflection point, the second derivative goes back negative. So this is f double prime of x, or the second derivative. So before we wrap this up, just remember that these sketches are not quantitatively accurate. The peaks and valleys might be a little different. You've just got to capture the sense of it. And in that case, what we're really saying is with the first derivative and the second derivative, where is it positive, where is it negative, and make a smooth curve that shows just that.
Now that you've watched the video, take a moment to write down any questions so you can bring them to our next class. Always remember, you can watch the video again to deepen your understanding. If you enjoyed the video, please click like and subscribe.